Hello and welcome to this episode of Science Club Daily. And today I'm actually joined by Debbie. Welcome.
Hello.
So Debbie, we are actually going to be on the Science Club show in just a little amount of time. But today we also wanted to talk about this interesting story about something that affects all of us, I guess, but also doesn't affect us at all. And that's the Milky Way galaxy, the place where we all live.
How exciting.
Yeah. I mean, I kind of like this because in a lot of ways, our galaxy is quite typical of a lot of galaxies, except it also turns out that our galaxy is not flat. So, I mean, obviously, when we see galaxies in space, they look two-dimensional to us just because of how far away they are. But obviously, the Milky Way is kind of like obviously a three-dimensional shape with some stars sitting above the center, some a little bit below. So the Earth actually, like the solar system, isn't quite in the main plane. It sits slightly above, and it actually goes in and out like a sine wave, going higher, lower as it orbits the galaxy. But it turns out that our galaxy isn't completely flat. It's kind of warped, a little bit like, I guess, like a Pringle. Is kind of the best example I can think of. And for a long time, it hasn't really been known why this is. So we've had the ability to see this since the 1950s because obviously there's a lot of stars and we can kind of see based on their shape that they're not actually a flat disk like you would expect from a lot of disks, but we actually have this kind of warp happening. And there's been a few different theories about why this is. So do you know about dark matter?
Kind of vaguely. I'm not a physicist.
Yeah.
But, everyone hears about it, definitely.
Yeah. So, I guess for people who don't know, dark matter is this idea that there is some kind of mass in the universe, because we know that all mass has gravity, that essentially if we look at all of the gravity that exists in the universe, and then we look at all of the mass that we know about, there's this discrepancy where there should be more mass, but we don't see it. And so they call it dark matter because we can see its effects. Things like gravitational lensing are kind of proof of that there is matter out there that we just can't see or detect right now. And that was one of the ideas. It turns out that a lot of galaxies have what they call a dark matter halo, but they actually don't think that in this particular case that is what's causing it. And they also have these theories about something like intergalactic magnetic fields, which sounds very Star Trek-like, but
very sci-fi.
Yeah. But here's the thing. The problem is that the warp itself, the way the stars are orbiting this warp, so you can imagine as they do the orbit of the galaxy, they're sort of moving along this warp. And there is this new satellite called Gaia that has been, it's basically one of the best satellites to look at the Milky Way that's ever been launched. And it looks at like 1 billion stars in our galaxy, and it takes pictures of them in fairly short spaces of time, which means that we can actually see how quickly stars are moving. And it turns out that these stars in our galaxy are actually moving too quickly in order for dark matter or these magnetic fields to be behind it. And so obviously that leaves you wondering, what is behind it? Now,
well, I mean, it's always such a strange thing to say, hey, this is really different from what we know. But when you're already dealing with so many unknowns and so many guesses and looking at things where we can see the effect that we can't actually see the physical matter of it, it just adds so many more dimensions.
Right, especially the universe has so many of these things that because the universe is big, we can see the effect of things, but we can't always detect them. So our sun orbits the galaxy in basically 220 million years. And it turns out that the warp, the effect of this warp moves around the center of the galaxy about every 600 to 700 million years. And as I said, this is too fast for the explanations that we favored in the past. And basically what this means is that something a lot more powerful must be causing it. And the best explanation for that is that there's actually a smaller galaxy that is interacting with our galaxy, that is actually basically in the process of colliding with the Milky Way. and that is the reason that the Milky Way is warped the way it is.
Yeah, that's really, really fascinating, especially if you're thinking it in the way of looking how galaxies interact with each other. And we already know they have interaction. All celestial bodies have that kind of that pull between them.
Yeah,
But when
exactly.
you're really looking at, well, maybe this effect that we're seeing, which is literally keeping us in motion, and on the very small scale of it compared to galaxies, keeping us in a phase essentially where we can produce life, is due to a potential devastation of our own galaxy.
Right, that's it. Like we don't know what the like the our solar system, how that would have formed if this wasn't happening right now. And it doesn't
Exactly.
take much to throw up this balance of what means that that of the way that life can exist. And we actually have a similar story. So if you want to go back and watch the Science Club show from yesterday, you'll see that we talk a little bit about a protein that was discovered on a meteorite, which is quite exciting and means that life could potentially form in a lot of places, which will be really interesting.
Yeah. I think it really challenges what we perceive as balance as well. I know
Yeah.
our, scientific vernacular has a very different type of jargon to everyday vernacular, but it does really look at sometimes the definitions we use in science are so far removed from what we have in everyday life, and looking at that already causes problems. But even within the scientific community, we are always refining our models, we are always refining our science, and we are also trying to refine literally the language that we use. And I think this is one of those things where we kind of look at balance as though it's everything in play, keeping things going. But
Yeah.
sometimes balance is only due to something that may end up unbalanced.
Yeah, it's kind of like a weird quirk of the universe where like a lot of balance actually comes from chaos.
Exactly, exactly. And I mean, that excites me, might not excite everybody.
I think that's exciting too.
I think it's pretty amazing.